So today in this video, I'm gonna try to explain and to help us understand in mathematics what are called linear functions by using a graphing tool, an online graphing tool, and it's available on this URL. I'm gonna put this URL as well in the comments in case you need to use it. So in mathematics, we have a linear function. So specifically in analytic geometry, so linear functions are representations of a line. So for example, in plane geometry, we can just use this to represent a line. It's a ray. In English, we can just write the word line and it represents a line. In analytic geometry, which is this one, represented by a Cartesian plane, there are several representations of a line. The most common equation, not the most common, but a general equation of the line in analytic geometry is in the form, it is called the general form, and it's like this. It's ax plus by plus c equals 0. Okay, but this is not the topic of this video. For this video, we're going to use the most commonly used representation of a line, which is the y equals mx plus b. This is called a slope-intercept form of a line. Okay, so what does it mean when we say slope-intercept form? Okay, so y represents all of the points in the vertical line here. So these are all the points in the line, while x represents all of the points in this axis across the horizontal. So m is called the slope. And the slope is basically, in layman's terms, it basically informs us how steep is the line. So we can say, for example, we are on a road, usually like a 10-degree angle. And so basically we can say that if we're driving in a car, we can say that the road is steep. But imagine a road which is inclined at a 45-degree angle. That would be very steep for a car to climb. So in mathematics, a slope, in layman's terms, this is just what we call the rise over the run. So the rise is the change of the vertical value, while the run is the change of the horizontal value. So we're going to try an example equation here. Let's say y equals 2x plus 1. Okay, so this equation, we can say that the m is equivalent to 2 and the b is equivalent to 1. So we're going to try to graph this in this online tool. So we can say 2x plus 1. All right. So this is the function or the equation, y is equal to 2x plus 1. And the independent variable, which is the x, and the dependent variable, which is the y. So the y is dependent upon what the value of x is. Say, for example, at this point in here, the value of x is equal to 0. And it's independent. And the value of y is computed by this. So we have 2 times the value of x, which is 0, plus 1. And so the y, which is the dependent variable, is 1. Okay, now if x is equal to 1, based on this equation, we have a y which is equal to 3, and so on and so forth. So the graph looks like this. It's kind of a steep slope. The slope, which is rise over run. So basically, for example, in this graph, you can see here, at this point, the value of y is equal to 5. And at this point, the value of y is equal to 3. So the change in the rise is how many units? The rise is 5 minus 3. And the run, at this point, the value of x is 2. Well, at this point, the value of x is 1. So you have 5 minus 3, which is 2. That's the rise. And the run is 2 minus 1, which is equal to 1. So that's 2 divided by 1. So basically, the rise is y2 minus y1. And the run is x2 minus x1. So the slope, m, or the slope, is equal to the rise divided by the run. In this case, m is equal to rise, which is 2, divided by the run, which is, let's say, why would you do that? 5 minus 3, this is the rise, and the run is 2 minus 1. So that is equal to 2. That is equal to 2. That is why in this example, the slope is 2. What is this y-intercept? So the y-intercept, in layman's terms, the y-intercept is the point in the y-axis, and we know that the y-axis is this one. We're going to try making it big. Okay. So the point in the y-axis where the graph crosses. So in this example, what point in the y-axis, this vertical line here, where this graph crosses? It's clearly very easy to see that that point is when y is equal to 1. So it crosses the y-axis at the point when y is equal to 1. So that's the y-intercept. And so without looking at this, when you have an example of, like, say 2x plus 1, you can now visualize in the graph that this is a line that is very steep because the slope is 2. It's very steep. And it crosses the vertical axis at the point of 1. So it's very easy now to visualize using this. You now have a visual idea. Even if I'm gonna close this graphing tool, you now have a visual idea of how this equation looks like. For example, we're gonna change it to 2x, still the same slope. Okay, so it's still the same steep line. However, we're going to intercept it at -2. So it's going to intercept here. So we can say -2. So this is where the line intercepts the vertical axis. Now we can edit the slope. How about a slope which is 1? So you can just say 1x. Okay, so in that case, 1x is just, as we have understood that the slope is the rise, in this case, the rise here is, from this point, it's 1 minus 0, which is 1. And then the x is also 1 minus 0. So 1 divided by 1 equals 1. So we can say that this is a 45-degree inclined line. So that's 1x. And then we can shift it up or down by using the intercept. So if you want to intercept the y to 1.5 here, somewhere here, so you can just say plus 1.5. All right? So that's what it is. Okay. Now, of course, this one, you can just remove the 1. You can just say x plus 1.5. And it's the same. Now, how about 1/2, a slope of 1/2? So you can just say 0.5x plus 0. So here, the slope is 1/2. So it's kind of like a slope which is not very steep. And we intercepted it at the point of origin, which is here in the 0. Now, how about a negative slope? So we can say negative 2x. Now, that's a different line now. Now, we can say negative x plus 1. Okay, so it's negative, meaning you're going downhill. And the slope is 1. So you're going downhill instead of climbing up from this direction to that direction. And you intercepted it at the point where y is equal to 1. So that's how it is. It's very easy to get a visual of a line which has the slope-intercept form. So as a review, this is the slope-intercept form of a line. Examples are this one, or negative 2x minus 4 or 5. And we can use this tool in order for us to get a visual of how it looks like. That's it. Thank you.